Hello and welcome to another video by Kono Insight. This video will discuss the mathematics behind constant returns to scale. A constant returns to scale is an idea which is embedded in the Cobb-Douglas production function. Before watching this video, you should watch a previous video regarding what the Cobb-Douglas production function is and how it works, and of course how it is derived. So now let's get into it. Constant returns to scale is a philosophy, is an idea, is if you double inputs, then you double outputs. It's fairly intuitive. Think about it. If you do something and you double inputs, of course you will double outputs. What we're doing now is, how do we prove that this characteristic holds in our Cobb-Douglas production function? Our Cobb-Douglas is used to model production, right? How inputs create outputs. How do we make sure this characteristic holds there? Let's go. Now, one thing before we dive in further is that in constant returns to scale, production functions which is constant returns to scale, the powers here, the exponents, beta in this case, and 1 minus beta, must add up to 1. So beta plus 1 minus beta equals 1 in this case. Why? Because beta minus beta is 0 and 1 equals 1. So when we have this characteristic, then we have constant returns to scale. So that's one thing to check. So now let's prove, why does this hold? Why does constant returns to scale hold? So we have our Cobb-Douglas production function. I'm going to write it all out. If you forgot what each variable means, check out the previous video. Now let's say I am trying to double inputs. So what do I do when I double inputs? I multiply things by 2. So I multiplied 2, my capital, by 2 because I'm doubling them. Don't forget the power exponent, which is beta. I multiply by my labor by 2. Don't forget the power, which is 1 minus beta. We're going to manipulate this and see how we can see constant returns to scale. Let's see. In this case, we could bring up the 2 up front. So we have 2 to the power of beta, don't forget the powers here, multiplied by 2 to the power of 1 minus beta. So we got that. Multiplied by the rest remaining. So that's AT here. Multiplied by KT to the power of beta. And LT to the power of 1 minus beta. Then recall the rules about exponents. We have here the same base, which is 2. And we're multiplying it. So what does it mean? That means we're adding it. If we add beta and plus 1 minus beta, that equals to 1, right? So that's a side note. I'm gonna move it here. That's a side note for you guys. So that's that. So beta, when we multiply this, we combine it to the power of beta multiplied by 2 to the power of 1 minus beta, we get 2 to the power of 1, which is 2. So we put it there, multiplied, then we just put the rest here. AT multiplied by KT to the power of beta, then multiplied again by LT to the power of 1 minus beta. So in this case, we can see that if we double the inputs, we multiply the 2 here inside, double the KD, multiply the capital by 2, and multiply the labor by 2 because we're doubling the labor. If we manipulate the equation here, then we can see that we're doubling the output. Why? Because we're multiplying 2 here. So of course the output doubles. And that is why constant returns to scale holds. We double the inputs, we double the outputs. We multiply by 2 here. And before I forget, and I should remind that constant returns to scale only happens if the exponents, in this case beta, plus 1 minus beta equals to 1. When that happens, then you can prove this whole bit here. Thank you for watching, and I hope it helps.